Video 10, Classical Science, the basic issues. We have already explained that science started after the Renaissance happened in European countries during 15th century. The first stage of Renaissance was enacted in Italy and subsequently it spread into other Western countries. This cultural upheaval has three broad fields, namely Industrial Revolution, Scientific Revolution and Reformation in religious organization. The advancement of scientific revolution was powered mainly by the new discoveries in the various branches of science like physics, chemistry and biology. Here it is helpful to distinguish between physics and chemistry. Physics is the study of the general aspects of physical things by focusing on its measurable properties. Accordingly, physics is concerned with the common aspects of physical things as well as the structure of physical world in totality. On the other hand, chemistry is the study of the individual things and its components engaged in chemical reactions. Accordingly, physics can be treated as the basic science. When we want to study the fundamental aspects of science, including the origin of natural world, we must concentrate upon the features of physics. Now it can be stated that science advanced in the last 5 centuries on the basis of the discoveries of physics. From the historical perspective, there are 4 phases of development of physics called classical physics, quantum mechanics, quantum field theory and quantum cosmology. Classical physics assumed that the basic unit of matter is atom. On the basis of this assumption, various scientific disciplines like chemistry and biology were developed during the period from 16th to 19th centuries. They together formed the area of classical science. In the beginning of 20th century, the principles of quantum theory were discovered regarding the constituents of matter. It is the beginning of quantum physics, which can be divided into 3 main stages named above. Consequently, the entire range of physical subjects have been recast using the principles of quantum theory. The term modern science refers to this development of last century. In the present video, we are interested in the salient features of classical physics. The scientific revolution started in 15th century with the discovery of Copernicus that Earth and other planets revolve around the Sun. Thus, Ptolemy's geocentric theory was rejected and the new heliocentric theory gained prominence. Afterwards, Kepler used physical variables like place, time, distance and speed to formulate laws regarding the movement of planets. At the same time, Galileo, using his newly invented telescope, made significant celestial observations and conducted experiments on moving bodies. It was Galileo who articulated firstly that science has a distinct methodology based on the physical approach of study. The scientists of that period accepted the view that the world moves due to definite physical laws and hence it is like a machine. The method of physics is to combine mathematical concepts and sensory observations to formulate the mechanical laws pertaining to nature. This mechanistic view reached its zenith in 18th century when Isaac Newton discovered the laws of motion and the law of gravity. In retrospect, Leucippus and Democritus of ancient Greece originally advocated the notion that the basic stuff of world is matter, which consists of minute and indivisible particles called atoms. Their theory is known as atomism. This legacy was elaborated by Galileo, Descartes, Isaac Newton and others to establish the mechanistic worldview. Specifically, Isaac Newton was concerned about the movement of bodies made of matter. He asserted that motion requires energy which ultimately comes from gravitational force, the origin of which was God. Obviously, Newton adopted the religious faith in Creator God who caused the first motion of heavenly bodies. He envisaged that the laws of motion are uniform in all parts of space and time, and it justifies the notion of mechanistic world. The defining basic assumption of classical physics was that the physical things are made of atoms, which are minute and indivisible particles of matter. In other words, matter is a homogeneous substance and its unit is atom. So far, scientists have discovered about 110 varieties of atoms differing in size. Energy is required for the motion of atoms and higher order substances and also for chemical reactions. On the basis of the notions of matter and energy, classical physics has defined various quantifiable concepts such as weight, mass, force, space, time, length, breadth, height, distance and motion. Obviously, the idea of time comes from change or motion and hence from energy. Another important assumption was that matter and energy are mutually independent entities and it constitutes the physical world. It is interesting to note that almost all machines and appliances of our daily life are working on the basis of the laws of classical physics. Various kinds of motors, fans, vehicles, aeroplanes and rockets are clear examples. The more wonderful fact is that all the astronomical objects such as Earth, Moon, Sun and other stars move according to the classical laws of motion. But the gadgets of electronics such as computer and mobile phone are the products of modern physics. In spite of the numerous applications of the laws of classical physics, it has many drawbacks and puzzles to be mentioned below. The basic assumption that matter and energy are independent and separate cannot explain the origin of various radiations like light and X-rays. Is there any evidence that atoms exist in the form of minute and indivisible particles? 3. There is no satisfactory answer to the question what is the original cause of the natural laws that govern the accurate motions of Earth, Moon, Sun and other stars. 4. Since the origin of atom and energy is shrouded in mystery, the ultimate question about the origin of physical world cannot be answered through classical physics. Considering the above controversies and puzzles, we want to embark on the systematic inquiry about the validity of scientific knowledge, contrasting it with religious belief. Naturally, we are led to the deeper question about the nature of various kinds of knowledge generally. This is the topic of our next video. Please subscribe to this YouTube video series. Thank you for watching.